This chapter, we're starting on chapter 1. We're going to be talking about parallel lines today and their related angles. But this chapter, you're going to have a bunch of vocab. In fact, on your chapter test, you're going to have some terms you need to define. That's a chunk of your test. So at the end of this chapter, you'll need to know these terms. And I gave you the back of one of the note pages you picked up on the way in. But as we go through them, on the days we go through them, you should just have this page out and just write some of these definitions down. Usually it can be done with a picture, just describing the different terms, as you'll see with some of these today. And some of them you may already know, but it's not meant for you to just sit there and crank out definitions today. That's not the purpose. The purpose is so you know, and then as we come through and go through them, like there's one I'm going to add to this called a transversal. But as we get to those, and that's one of the terms we'll get to today, you can make a note of it in some way. The transversal there. Okay? Any questions? All right. Moving on. So we're 7-1, parallel lines and related angles. This is page 363 to 368 of our textbook. Okay, our goal is to identify the pair of angles formed by two lines and a transversal, and relating the measures of those angles with parallel lines and a transversal. Okay, so that's our goal. I'll give you a second there to copy that down. All right, so some definitions. Page 363, a transversal is a line that intersects two coplanar lines at distinct points. In other words, a transversal is a line that goes through two other lines. That's a transversal. Now, the type of transversal we'll talk about a lot is a transversal that intersects two parallel lines. This is the picture you see a lot. This is the famous picture, like the Mona Lisa of transversal and parallel lines. This is also a transversal, however, these are not parallel lines. Okay? That's a big deal. This is a transversal, these aren't parallel lines. Lines cut by a transversal that do not have, the lines do not have to be parallel. However, the special properties that we talk about having congruent angles and supplementary angles, are only formed with a transversal that cuts through parallel lines. So this is the picture we are going to be referencing tons in geometry this year. Okay? This is just, hey, that's a transversal. All right. Yay. Now we're moving on. This is a transversal that intersects two parallel lines, which means I know a bunch of things. I know this and this add up to 180. I know that this is congruent to that, and that is congruent to that, and that is congruent to that, and that is congruent. There's a lot of things I know from this picture because it intersects parallel lines. Here I don't know any of those things because it's not parallel. It doesn't intersect. All right. Very good. That's one of the things you need to define, transversal. Yes?
On the non-parallel one, though, wouldn't it still be like
What?
the axis 180 because it's like a straight line, or would that not?
Nah, not necessarily, no.
How do you word it? Yeah.
Hey, think about these. You can, hey, Logan, you can pinch these two lines together and these angles get infinitely bigger. Okay, so it doesn't necessarily have to do that. Okay, so postulate 7.1 deals with our special type of transversal. If two parallel lines are cut by a transversal, then their corresponding angles are congruent. Okay? If two parallel lines are cut by a transversal, then their corresponding angles are congruent. Corresponding angles mean if I were to cut this part out right up here, and I were to cut this part out down here, and I were to lie those two set of four angles on top of each other, angle 1 would lie on top of which angle down here?
5.
Lie on top of 5. Those are corresponding angles. Okay? Those angles are congruent. Angle 2 corresponds to angle 6. They're corresponding. They're congruent. Angle 8 corresponds to angle 4. Okay, so corresponding angles are congruent. Then obviously 7 and 3. Okay. So if we know a transversal intersects parallel lines, then their corresponding angles are congruent. That's one of the pieces we know. So one of the definitions you had was transversal. The other was corresponding angles. Okay, those are two things that you can make sure that you've defined. If you're using that other sheet, maybe that's a sheet where you just check them off or you summarize it later on. Okay, but there are definitions you need to be able to, things you have to be able to define by the end of the chapter. All right. Next one, alternate interior angles, theorem 7-1. Okay, if two parallel lines are cut by that transversal then, so once again we have the parallel lines transversal, then their alternate interior angles are congruent. Okay, alternate interior. So when I say alternate, I mean opposite side of, alternating sides of the transversal. So like if I say angle 5 and angle 4. Those are inside the parallel lines and on alternating sides of the transversal. Alternate interior angles. Alternating sides of the transversal inside the parallel lines. Those are alternate interior. Okay. Tell your neighbor another set of alternate interior. Okay, so 5 and 4, and good, 3 and 6. Okay, alternate interior. Bethany.
How would you define that?
Alternate interior?
Yeah.
Well, I would define alternate interior as angles on opposite sides of the transversal inside the parallel lines. Okay, you don't necessarily always have to put it into words though. A picture is a good way to define. Like if on your test, if you drew this picture and pointed those two out and said 5 and 4 are alternate interior angles, they're congruent, that's a good definition. That's the most important thing in your notes, is that you're able to define what's going on for yourself later on. Zach, you with me?
Yeah.
What, you know why I asked those things?
That's what?
Like, are you with me?
That is, it looks like I'm not paying attention.
Okay. Why would that be? Yeah, okay. I was just checking. I want to make sure you know. All right. So if that's the case, then what should you do? And yeah, very good. And you guys, it's not always about if you're talking and you can pay attention, which research actually shows divided attention you can't do. But whether or not you believe that or not, it's the people around you that get distracted, or the presenter who gets distracted because you're talking. All right. So 3 and 6 we have. Okay. What are alternate exterior angles? Yeah.
They're like the opposite angles but on the outside, so like 1 and 8.
Good. 1 and 8. Opposite angles, but on the exterior of the parallel lines. So 1 and 8. Yeah. Yep, they're congruent as well. Yeah. So alternate exterior would have angle 1 is congruent to angle 8. What's another set? Yeah.
2 and 7.
2 and 7. Angle 2 is congruent to angle 7. All right. We also know they're congruent. So these guys here. So we'll put a triangle there or something. Okay, so we have alternate interior and alternate exterior. They're congruent. We have corresponding angles are congruent. The last piece that we're going to go through right now is same side interior angles. So angles on the same side of the transversal, interior, meaning inside the parallel lines. So tell your neighbor what two angles are same side interior.
Oh, is it 5? Yeah, 5 and 6. Right? Is it on the
All right. James, what do you think?
Yeah, because
Take a
on
guess.
the same side and on interior.
You probably don't need a guess, but take a guess anyway. Here, 3 and which one? 3 and 5, yeah. Okay. They're on the same side of the transversal and inside. Same side interior angles. Same side interior angles are supplementary. So that means you have to know what supplementary means. We've talked about it. What is supplementary?
Angles add up to 180.
Adds up to 180. So the measure of angle 3 plus the measure of angle 5 adds up to 180 degrees. They're supplementary. All right. Tell your neighbor another set of same side interior.
6 and 4.
Yeah.
Good. So we got 6 and 4. Okay. Measure of angle 6 plus measure of angle 4 equals 180. All right. Questions? Okay. Let's see how we do on these. Find measure of angle 1 and measure of angle 2 and state the theorems or postulates that justify your answers. Work with your groupie there. Okay, so Chase says that it's same side interior angles. How many agree with that? Okay, we abbreviate it like this, same side interior. Those are same side interior. We have parallel lines because of this marking. Same side interior. And what'd you say angle 1 was, Chase?
Angle 1 was 75 degrees.
Okay, how do you know that?
It's the opposite of, well, it's what adds up because they're supplementary for 2, and 2 is like supplementary to 75 on the other side, and so 75 minus 180 equals 105 for 2.
Okay,
So,
so you're actually going this right. You're saying that, hey, this and this, it makes a straight line, so that's 180. And that makes that 105, and since these are same side interior, that makes that 75. That's true. That works out. What's another way of thinking about it? Go ahead, Bethany.
That 1 and 75 are the same.
What do we call those, Grace?
Corresponding angles.
Good. So you could say 1 and 75 are the same based on corresponding angles. And then angle 2 is 105 based on same side interior. So there's two different ways you could go about it. You could say supplementary and same side interior. You could say corresponding and same side interior. Now the important thing is if you're doing an exam on this, you have to be able to explain which one you used. So if you found angle 2 first, usually you go in the order that they gave you. If you found angle 2 first, you would want to say supplementary with angle 2 and then same side interior. Okay? Good job. Questions on that? All right, try this one here. Find angle 1 and 2, justify your answers there. Justify your answers. Use the postulates or theorem.
So is angle 1 is corresponding to angle 5? So it's
120.
Yeah, so it's 120.
And 2 is 8.
Yeah, because of the supplementary. Yeah.
And then,
Yeah.
so,
That's not good. It's like rooting for the cheaters. That's all right. Yes.
Wait, do we get to see our finals?
We could, yeah. Do you want to?
Well, I just wanted to know, because like, I got,
Yeah.
I guess extra credit on it.
There's some extra credit. We'll talk about it here in a few. Okay, angle 1. Angle 1. What do you got there, Emily?
They're corresponding, so it equals 120.
So based on corresponding angles, this is 120. Okay, so we have the parallel lines corresponding 120. Angle 2? Maggie?
If you do a supplementary, making it 60 degrees.
60. So you could use supplementary here, or you could use supplementary, same side interior here. Either way. Very good. How many got those? All right. So corresponding and supplementary are same side interior. All right. Couple more. Try that one there. So again, find angle 1 and 2. State the postulates or theorems that justify your answer. Bit tougher.
Wait.
Okay. Here we go. Yes, Grace?
So number 2 is 70 because how I did it was the other angle, since those two angles are supplementary, the other one would have to be 110, and then same said interior angles, the other one supplementary.
Okay, so I'm going to extend this line. Grace is accurate there. There's a couple ways to look at it. This is a transversal going through parallel lines. Okay, so she's saying that, look, this and this have to add up to 180, and this have to add up to 180. So these two have to be the same, right? The other way to think about that, those, like if you extend this parallel and that transversal, what type of angles are these?
Alternate interior angles.
These are alternate interior. So very true that's how we come up with the alternate interior, by the way. Okay, but alternate interior angles would work as well. This is 70. Now please note, does that make this one 70? No. In order for it to be alternate interior, they have to be on the same highway, if you think of it that way, the same transversal. You have to have a transversal touching both of those angles. Okay? There's not a transversal that touches 1 and 70. Now, we could figure out this one, right? Because we could figure out all these angles here. Like if this is 70 and this is 70, well, 70, what's that make this? If that has to be supplementary. 110. And if this is 70 and 110 and 80, what do the angles of a quadrilateral have to add up to? 360. So that's one way to go about it. The other way is you have another transversal in here. This is a transversal. Right? 80 plus what? Makes 180. 100. This has to be 100. So you could check it. We know they all have to add up to 360. Right? So that's 210, 290 and 70, 360. Hey, we're good. Okay? How many got them? There are multiple ways to go about it. Trying to use what we're learning today, I would use alternate interior and same side interior. Okay. Questions there? Okay, 2 more problems. I'm going to have you do this one while I'm handing out your assignment because the next one's going to come right off your assignment. But go ahead and talk to your neighbors about it. Everyone's eyes and ears up here. Okay, this is page 366, but measure of angle 1 and 2. No, 1 and 2. What do we have for 1? Good, Julie? 70. What'd you use?
I used the same side interior angles.
Good, same side interior. How about angle 2? Maggie?
Alternate interior angles for 110.
It is 110, right? But it's not because of alternate interior. Alternate interior, are you implying these two?
Yeah.
Hey guys, remember, just to make sure you have to have a transversal touching the two. Okay, so Maggie, what else could we use? Maybe like with supplementary or same side interior, right? These are supplementary. Good. Okay. So you got to use same side interior and same side interior. You can't use alternate. This one and this one you can't go with. You could actually say, by definition of a parallelogram, opposite angles are congruent. Is that what you're going to say, Cameron?
I was going to say the vertical angles.
Vertical. Like across here?
Yeah.
Yeah. So these two are vertical. I know what you're talking about. You're thinking going this way, but when we say vertical angles in math, we're referring to these two. But you're thinking of what I was thinking, I think. Okay? So you could say opposite angles of parallelogram would work as well. Okay, I want everyone to take a look at problem 16 on the example side of the sheet I just gave you. This given measure of angle C and measure of arc AB, find the circumference of the circle. Go ahead and work that out with your neighbor there. How are you going to do that? All right. Heard a few decent ideas, so what do we do? Julian, what do you think?
Multiply 14 by 4.
Multiply 14 by 4. What's that doing for us?
That's finding out the circumference of the entire circle because it's 90 degrees. If you multiply 90 by 4, that's 360.
Okay, so if you go 14 by 4, since there are 4 90s and 360, you can figure out what the entire circumference is. Okay, very true. Good. Anyone else come up with it? So 14 times 4 is definitely a valid approach. That ends up giving us, what is it, 56. 56 inches. That works out. Maggie?
Set the ratio of 14 over 90 equals x over 360.
Okay, so 14 is to 90 as x is to 360. So up here we're kind of dealing with arc is to degree. So arc over degree, right? Yeah, very good. And you guys, the benefit of, like 14 times 4 is definitely, I mean, in a problem like this, we should be able to recognize there's 4 90s and 360. You multiply 14 by 4, you have it. I'd hope we can do that. Okay, the problem is when we get tougher problems like 71 degrees. Then we want to have a proportion. Okay, where we could say, well, if 14 is to 90, as x is 360, cross multiply and divide. Once again, you end up with 90x equals, I don't know what 14 times 360 is. What is that?
5,040.
Yeah.
5,040? Is it 5,040?
Yeah.
Okay. And then divide by 90, we get x equals, hopefully 56. Okay. All right, good job. Any questions there? You guys did really well with that last semester, so I'm not too terribly concerned about it. Your assignment is both sides. Not as complex as it looks. You should be able to finish a huge chunk of it before you leave today. Beth, any question?
On the example side,
Mm-hmm.
on 2, 5, and 6,
Mm-hmm.
if the lines aren't parallel, then like how would you
So good question. If the lines aren't parallel, so like number 2, is this a transversal? Can you have transversal and non-parallel?
Yeah.
Yes. Even though it's not parallel, 1 and 2 are still alternate interior. However, are they congruent? No. They're only congruent in the parallel line ones. But we still call them alternate interior. Good question. They still have the same names, just with parallel lines they have special properties. They have special powers, man. It's like the Teenage Mutant Ninja Turtles when I watched it yesterday on TV. Pretty good. Questions? Other than why I was watching it? It's pretty good. I watched it when I was a kid. So I watched the movie. It's really good.
I want to be like the Ninja Turtle.
It's good.
One or the new one?
The new one.
Like, 'cause shooting me